Hello and welcome back to the channel. In today's episode we're going to be learning all about how flowcharts can be used to create a program. That's all part of core content section 1.7, Programmable Components. In that we're going to have a look at how it allows you to add an intelligence to an electronic device or product. Let's get started. Okay, so for those of you that are unfamiliar with flowcharts, here's a few rules we need to follow. Now, essentially, the flowchart is a way in which we can plan the programming side of things. It's essentially where a computer would have a series of questions which will give it yes and no answers. Those yes and no answers will allow it then to make decisions based on what we've decided to program. If you're not familiar with how flowcharts work, have a look at these symbols down below. This oval looking shape here is what we have as our start, so the computer knows where to begin its program. Over here at the rectangle we have the instructions telling the program what to do at what part, and then lastly we'll have these diamonds, and these basically make up the decisions. So with a flowchart we have three different shapes: the oval telling us our start point, the rectangle which is our instruction, and of course our diamond which makes our decisions. Let's see if we could put that into a sample over here. So down here we have our light bulb, and that's going to come on and come off, and we're going to be using an electronic component, for example here, such as an LDR or Light Dependent Resistor. Now a light dependent resistor is quite interesting because what it does is, if you imagine your smartphone, at the top above your screen you have a piece of plastic, and behind that is a light dependent resistor. Now what I want you to do is go ahead and phone a friend or phone your gran or someone who you know is going to be able to ring for a couple of rings. As it's ringing, take the phone away from your ear and have a look at the screen which will be on. If you take your hand and cover the front top part there, you'll notice that the screen goes blank. What that is it's a light dependent resistor telling the computer inside the phone that the area around it is dark, or it's close to your ear, therefore to save battery life we're going to turn off the light. So you'll notice the screen goes completely dark. When you take your hand away and you allow light to get back to it, the screen will go, okay, we're in light now, we need to put the screen back on. And that's how a light dependent resistor works. Have a go at home. Okay, so here we go. We're going to start our program off nice and simply, and we're going to give it our first instruction, which is turn light off. Okay, so we started off, the computer knows, right, we're going to start this program and the light's going to be turned off straight away, so I'm going to make sure the light's turned off because I don't want to waste battery life. Now the second part is, of course, after our instruction, is that decision in that diamond, and we're going to say, is it dark? Now if the answer here is no, we're going to have a feedback loop here and say no, and it'll go back round again. So is the light off? Yeah, okay. Is it dark out there? No, it's not dark, so we'll keep the light turned off then. Now on the other hand, if the answer becomes a yes, it is dark, well, we want the light to turn on. Turn light on. And that then becomes the end of our program. We start, the light is turned off. Is it dark? No. Keep the light turned off. Is it dark? Yes. Well, I want to be able to see in the dark, so turn the light on. Now, I did mention before previously, very briefly, about this thing over here called a feedback loop. Where it loops back round again, and it will keep going round and round and round as long as that decision is saying no. Now, to make sure the circuit works over and over again, we're going to have another feedback loop here just before the end, and we're going to go all the way back up, and we're going to come in here like that, and we'll call this feedback loop 2. That could be feedback loop number 1. So what that means then, if I show you with this blue pen, is that we will have the light turned off. We'll start the program, the light will be turned off. Is it dark? No. It'll go back round and stay off. Is it dark? Yes. Then the light will turn on. Then of course then we will go back. There we go. We'll feed back round here and we can ask the question again. Then it turns dark. Is the light dark? No. Then it will feed back round and turn the light off. And that, ladies and gents, is how we use flowcharts to create a program. And we use the flowchart in a way to plan that program out. So, what have we learnt in today's session? Well, we've learnt about flowcharts. We've been able to identify now the three shapes used to use those flowcharts. We know that the oval, of course, is the starting point of our program, and that rectangles are our instructions. We learnt that the decisions being made, the yes or no parts for the computer program, are created in a diamond. We've then had a go at a worked example, learning a little bit about what's called a feedback loop, and seeing how that program can be automated so that it never ends, but also so that it can turn on and turn off without the touch or the use of a switch. So there you have it, ladies and gents, programmable components, part of the core content 1.7 for the DT GCSE. Until next time, stay safe. Don't forget to subscribe. Bye now.